We're going to discuss non-homogeneous differential equation. First, we are using the differential equations which are homogeneous. And you know the non-homogeneous differential equation is, in homogeneous differential equation, y equal to 0 is the solution. That's to check it. Or each of the terms contain y, we say homogeneous. Now we have the equation, for example, I just take example for this one. We're having here a d2y by dx square. Obviously, leave it a. We have d2 by dx square plus 2 dy by dx plus 5y is equal to x square. Now this equation, due to this x square, is non-homogeneous. In general, we can say we having any differential operator phi d, then y, and we say is equal to f of x. If I just rewrite this one, I can write here this is equal to d2 by dx square. So 2 d by dx plus 5 into y is equal to this x square. So this whole thing we write here phi d is any one, and this one we write here f of x. So this is equation which is non-homogeneous. We are going to study it. This f of x we can say can be any function of x. So we are having two methods for solving it depending upon the value of f of x. If f of x is polynomial function, or f of x is the exponential function, or f of x is the sine cosine function. So we are having a method, we call this method as undetermined coefficients. Undetermined coefficient. If our function is not from these this three category, it can be a linear function, it can be a tangent function, it can be any exponential function. So we call that transcendental functions. If it's not from there, then we have the second method. Our second method is variation of parameter. So at the first stage, we are going to discuss undetermined coefficient. Now, when we are having here the function which is non-homogeneous differential equation, then we are having here two parts. We just divide in two parts. Part one of this one, we take it that this is our, in the case we are having here two parts. Part one is phi dy equal to 0. Then we take homogeneous part. We take here the homogeneous part of the differential equation. And we have already discussed the solution of the homogeneous part of our differential equation, and we have already knowing that on how to find the solution of the homogeneous part of the differential equation. That's not difficult for us to solve that one. The second part of our problem will be the homogeneous part. This is due to f of x. Then we say here we get here solution. We say it's yc. The second part is the solution which is going to satisfy the whole differential equation, and that we say is a particular solution. That is due to the non-homogeneous part due to y, and we write this the particular solution as yp. So again we have two steps of solving it, and here this particular solution we find with the method which is known as undetermined coefficient. This we know. We put y equal to m of x and solve it, and we get the solution of this one. And here for this one, we go to undetermined coefficient, or depending upon the function, we go to the variation of parameter and solve it and get yp. So then this gives me the general solution. I can write my general solution. My general solution will be the combination superposition of these two, being y equal to, they are linearly independent, and we can write y equal to yc plus yp. That's my general solution. This part we know, and this part we will learn, this part, how to find it. Again, we have two methods, undetermined coefficient and variation of parameters. So we having the function, I take the function f of x is equal to x square. I take function f of x equal to x plus 5. I take the function f of x equal to x square minus 3, or any form of the polynomial function of any order. This is my first set of function. My second set of function was my f of x is equal to e to power 3x. My f of x is equal to x e to power 5x. My f of x is equal to any polynomial function of order x square plus 3x plus 2 e to power minus x. So it's my second set of function, where the exponential function. The third set of functions we can have here, my f of x is equal to sine 2x plus cosine 3x. My f of x is equal to sine 2x only. My f of x is equal to, I can have multiple of x sine 2x. I can have my f of x is equal to product of x e to power 2x sine 3x. So any combination. We can have here this number 3, but the function, when we having the function as sine cosine function, we can have any combination. I can have here f of x is equal to x square plus 3 e to power 2x plus sine 5x. So it's getting the polynomial function, exponential function, and sine cosine function. It can be of any form. So I will tell you that when we having the function in the form, what is our yp? Once we get the yp, and yp is solution of our differential equation, yp is solution of this differential equation, substitute in that one, and we find our arbitrary constant. Again, I would like to say that as we having part 1, we're getting part 2, part 3, more examples. So if you want to get the announcement for this one, then you subscribe our channel and also press the bell icon so you can get the all information about the coming videos, number 1. Number 2, we'll find more examples and my notes in the description. So I'll give you different type of functions and the particular solution for these functions. For example, I have the function f of x is equal to x square. Now we say f equal x square is a polynomial function of degree 2. So my yp will be a general form is equal to a x square plus b x plus c. This yp for any second degree polynomial. For example, I have the function f of x is equal to x square minus 3x plus 5. It will have the same yp. I have f of x is equal to x square minus 2 with same yp. So yp will be same for any function for this one. For example, I have f of x equal to x. So we have the yp is equal to ax plus b. I have here f of x equal to minus 3x, same yp. I have f of x is equal to 3x minus 5, same yp. So yp is not here. The idea is this is the yp is the function of order 1, degree 1 is of degree 2, and in any polynomial function, any form, we can have here this equation. Now this is for the function when we have the polynomial function. When we have the exponential function, for example, I am having here the exponential function f of x is equal to e to power 2x. One more thing which I want to say before going further, that is, if we're having here the function f of x as a constant. For example, I have taken all, but we have not taken this one. I have the function f of x is equal to 5. Where the degree polynomial is 0, so yp is equal to a. It can be any constant. My f of x will be equal to 200. So my yp will be equal to a. So it remains the same. So these are ideas, degree 0, degree 1, degree 2, representing by the same degree polynomial function. Now having the exponential function, for example, I have y equal to e to power 2x. So look on here the coefficient. It can be y equal to 3 e to power 2x. It can be y equal to 5 minus 5 e to power 2x. So for all of these, we get here y. We look on the coefficient. Coefficient is constant. So we get here a e to power 2x. So for example, we having either y equal to x e to power 3x or y is equal to x minus 2 e to power 3x. I get here y is equal to 3x plus 5 e to power 3x. So what's the coefficient? Here is degree 1. So yp will be equal to, here's yp, is equal to ax plus b. We look on the coefficient of the exponential function and we determine about the undetermined coefficient. For example, I have here y equal to x square e to power minus x. I have here y equal to 3x square plus 5 e to power minus x. So what's the yp? We look on the polynomial function here is of degree 2. So yp will be equal to ax square plus bx plus c e to power minus x. So that's how we can write the particular solution for case of the function, exponential function. For exponential function, we're looking at the coefficient. We're looking at the coefficient, and according to the coefficients, we're going to decide that what we are going to have. Here's coefficient is 1, here coefficient is 3, here coefficient is 5, here coefficient is x, x minus 2x, we're having ax plus b, here is x square plus 3x plus 5, second degree polynomial, we general form. So actually what we learned for the function when it's the constant of polynomial function degree 1, we're having the same idea here, and then just this the exponential value is coming along with this one.